Please write your occupation for our speaker to know the audience better and to adjust his presentation. Please use chat window for that. Thanks a lot. The organizers of this event are InventorSoft Group, and our CTO Maxim Goroshkevich would like to introduce you the series of webinars we're launching, as well as what the company is doing in general. We'll have some requests for you during this webinar. If you have some question, please write it down in the chat menu for Viktor to answer during the webinar. And for your convenience, we put you on mute just to eliminate the extra noise. Also, during the webinar, I'll share with you a link to Google Drive, to Google Docs, I'm sorry, where there will be a form with some information needed from you, like the feedback from the event, and also you can leave your email address so that we can send you the recorded webinar to your email. So, Maxim, are you with us? Can you tell a few words?
Yes. Hi, everyone. And thanks for joining to our invitation for this webinar. As Christina said, InventorSoft is a software development company specializing in building applications using Java and related technologies. We work at various projects and by different models, and one of which is SFox model, where we build remote development teams in Ukraine for the Nordic product companies. We are launching a series of webinars on the development practices for developers, project managers, CTOs, product owners, those who are interested in improving their knowledge in software development. Have a nice webinar.
Thank you, Maxim. As you know, today's speaker is Viktor. Viktor is working for our customer Mechai. This is an online booking platform which allows you to find a venue, find an opponent, and to play racket sport with this convenient platform. It also tracks user activity. Viktor has 14 years of background in IT, focusing on such technologies as Java, Spring, Groovy, Rails, Scala, AWS, and etc. Viktor, are you with us?
Yeah.
Cool. So we're ready to start.
Yeah, let's go ahead. Actually, a lot of stuff already said about myself. So yeah, I was in the industry for a while and tried so many different things. Those were Microsoft and Java products mostly, but also Python and other stuff. But recently I'm working only in Java ecosystem, and that's what I'm concentrated at. And this webinar particularly will be also related to Java. So I guess I will start from the topic. And so how I would like to build this webinar. I will share some slides at the beginning and we'll explain what the problem is and what's our advantages of using microservices. But I will interrupt myself a few times and we'll let you ask some questions. And that will be more interactive and I will better understand what you guys are interested at. Okay?
Would you share your screen? Oh.
Yeah, seems like now I'm sharing. Let me know if you can see it.
Yes, we see it.
Okay, perfect. So microservices with Spring Boot. Why microservices and why Spring Boot? Let's start from microservices. So standard problem why people would like to use them is the problem of monolith architecture. As an example, I just did today's screenshot of Amazon, because that's a service we all know about and we all saw it before. And let's see what we have in Amazon, like what different parts of the application we have in Amazon, but that we can say about absolutely every big service. So first of all, we have our shopping cart, and we have our user's account. We have different categories we can filter with, and we have what we are mostly interested in is our products, our items we can buy. And each item has some rating and comments. In general, those are parts that are independent. So if I have my account, that's not related to products unless I've already bought something, but in general, not. But all this works fine with the standard monolith approach. The monolith approach, it means that we have the one web application that we deploy to the application server somewhere. It has one big database with all stuff we have in the system. And that allows us to do something on the web page. That works fine, but let's imagine the situation that we have these stars here with ratings, and our CEO, the CEO of Amazon, said, let's do more interaction with our users. Let's encourage them to do more comments in the system. And we do the promo that you can write a comment and rate the product, and you will get the discount. And then all users started to comment and rate. What happens is that we have the big back pressure and we have the high load in the system. So in the worst case scenario, it can just crash. And because of commenting, nothing works in the application. If it's not too bad, it will be just very, very slow, but still not well functioning for our users. And that's a big problem for the business. So that's the one problem. Another one is if we want to scale this system because of this high load, we will need to create more instances of our application and deploy it somewhere to the cloud or to some data center. And we will pay a lot for this, even though we just need to scale our commenting system. To avoid all of this, we can use the microservices approach. Let's see what is the difference between monolith architecture and microservices. So for the monolith, as I said, we just have one user interface that calls the server. Server has everything we have in the application. All the data is stored in the database. Then server can call it, grab some stuff from it, and return the result to the user interface. So the first thing we can do to improve our system, just to split this big service to the separate smaller services. That is something that is called service-oriented architecture. Is it already microservices? No, but microservices are service-oriented architecture. So that's just bigger paradigm. So if we split it to separate services, those can be separate applications. It means that UI can call any of them separately without calling anything other. And it means that, for example, if service 1 fails, that our system is still functioning. So the UI will still, let's say that our comments failed, but we still can have the shopping cart, we can see our products, but just with no rating. So just not the end of the world. And services also can interact with each other, and they all still grab the data from the database. Then if we see the problem if in one of our services, we can scale it. It means creating more instances of that service. And that helps us to struggle with the high load. But I don't know if you guys already see another bottleneck in the system right now. So let's say if the problem is, for example, in the memory, that really helps. So we scale one of the services, but if the problem is in the database, that's our bottleneck right now. It means that we need to scale the entire database, even though we just need some small part. And there is where we need to do the true microservices approach. So each service has many instances, or can have one instance. It doesn't really important, but it's completely independent. It means each service has its own database, and it's isolated in its world. So as before, services can interact with each other, but only just through the API. So we don't really know how the other service works, and we don't need to. That's how microservice architecture looks. So that's the moment where I would like to start with questions. So any questions so far? Is it clear enough, or maybe you have something to add? Actually, I don't see the chat window, so I don't know if you're commenting something.
They are saying clear. Yes, it is.
Just a second.
But,
I will find it.
I think you can continue. No questions so far.
Okay, good. So now our task is to switch to migrate our big monolith application to microservice architecture. What we need to keep in mind are main principles that this architecture is built on. The first and very first is to keep services small and independent. As I said, each service has its own database. And if it becomes too big, that it has a lot of different stuff in it, it's better to split it to smaller ones. Then each service needs to be a standalone application. Why? And what does it mean to be the standalone application? It means that we can start the service itself. It doesn't mean that we need to deploy it, for example, to some application server. Because if we need to deploy all services to one application server, then they will share the same memory, and we will not be able to scale, because if we already have one service deployed, we cannot have the second copy of it in the same server. Then, since services are independent, we don't know anything about the user session. And that's what we need to keep in mind, that if we make the sketch for the API, the input needs to have everything that the service needs. So without need to call to grab anything from the session. So if we need to know anything about the user, then we need to know the service that I want to get this user profile. Then services needs to be fault tolerant, meaning that if the service fails, it should not break itself and other services. And the last, one of my favorite topics, but I don't know if we have enough time to talk about it. Each service needs to be asynchronous and non-blocking. That's not a requirement, but if we don't meet this, that will create a lot of problems in future for us. But I will talk about it more today when we start coding. So all big companies, all big tech companies like Amazon and Uber and all others already switched to that, but the pioneer was Netflix. And in all speeches about microservices, it's mentioned a lot, I think, because they not just switched to microservices, but created a lot of frameworks and libraries they open source for, and now community is developing that stuff, and it's available for all of us to use. So we know Netflix libraries like Hystrix. That's the library that helps us to meet the fault tolerance for services. Eureka is the library for service discovery. Today we'll use it and I'll show how it works. And Ribbon is load balancing plus also service discovery. That's a big framework that actually uses Eureka. Yeah, and the today's stack we will use for developing our application will be Spring Boot. Why Spring Boot? First of all, most of us are Java developers, and it's in Java stack. Also, it's Spring Boot is just a part of big Spring framework, and not all, but many Netflix libraries are already integrated in the last versions of Spring. So we have that right from the box when we start. It's easy startup framework, meaning that we don't need long time from scratch to have up and running. And very important, it has embedded Tomcat, meaning that our service will be standalone. Any questions now?
No questions so far. I think everyone is waiting for practice part.
Yeah, I'm disturbed. I didn't see the chat, but anyway, I will trust you. Okay, so
this button should be close to share screen and participants. If you can find these, the chat stands just beside.
Yeah, I don't see it.
We will help you.
Okay. So what we will create today. I was thinking about the topic and decided to stop on podcasts since it's very trendy now. And there are many startups appearing in the market dealing with podcasts. So we'll create a small system for podcasts, and we'll have two separate microservices that will interact with each other and with the they will work as the remote API, so our UI will be able to call it. And since we're using Spring Boot to create new application, we can just go to Spring Initializer. Just guys, you can now raise your hand if you ever used that. I'm sure that most of us did. So yeah, I have a chat finally.
Oh, cool.
Okay, so I will create two services. One will be user service and one podcast service. From the name, we can understand that one will do with podcasts, the second with users, but the user podcast will be able to call podcast service to get my subscriptions. And let's start from user service. We need to add few dependencies. I will add Lombok just to decrease the boilerplate in the code, and it will be easier for us to read. But it's not the requirement, and if you don't know what Lombok is, you will see. Spring Web, that's we need to create our controllers and endpoints for the REST service. Also, I'll add reactive web to make our calls non-blocking and asynchronous. And I will add Eureka client. That's what we'll need for the actual microservice ecosystem for load balancing and service discovery. Once I have everything added here, I can generate my code. And it will create the zip file for me. Then for podcast service, it's completely the same. So I just need to change the name. Once we did that, we have our Gradle applications created. I've already opened them, like just did the same stuff before, not to spend time for loading dependencies. And if we created Spring Boot application, that's what we will get at the beginning. We have the podcast service application class that can run the main method and start itself. So that's already functioning. We can start the service, but since we don't have anything inside, that's not really useful. So what I will start with, I will create the controller for getting podcasts. I will not do anything with the database, just to make it small and understandable for us. So I'll hard code the data, but that doesn't matter for our microservice approach. So first thing, to create the package for controllers. And the first class we need to have is podcast controller. So since we are in Spring, all we need to do to make it controller, just to say to add the annotation, REST controller, and here we are. It works, but we just need to mention what is the URL for it. So we say request mapping, and we say podcasts. So how I would like to make the data. So we'll have podcasts, 2 of them, and each podcast will have some episodes inside. So we need to have some models. Since they are not in the database, I'll hardcode them, but we first need to create the classes for them. One for episode. I'll delete it from here. Create a separate package. So we have episode and podcast itself. Now I will copy and paste some code already prepared for the webinar, just to make it quick. So what we have here, I'll explain line by line. So that's the simple model that has the episode ID, the name, and the start time, and the time where the episode starts. Nothing special. I just added Lombok annotations, not to create getters and setters, and Lombok will create it for us. And very similarly, we do stuff for the podcast. It has the same bunch of annotations. But here also we have the list of, so we have the ID of the podcast, its name, and the list of episodes. And now we're ready to create our REST controller. So for the REST controller, I need to hard code some data. Again, have something already prepared. So that's how it looks. Some importing stuff. So for Ukrainian part of the audience, you probably know all of these mostly YouTube channels. They are very popular, like TV Toronto and Geek Journal. But let's imagine they do podcasts as well. Probably they do, but I just didn't research that. And for TV Toronto, we have 2 episodes, one about Levytskyi, our politician, and the second episode about our president, Levytskyi. We have the start date times for it. So that will start today and tomorrow in the same time and 11 p.m. And Geek Journal will have 1 episode starting today at 4 p.m. Actually, it's already finished, but not as important. And we need to write some endpoints that will be available when we start the application. So we will do the method that returns the podcast when we give the ID. So we provide the ID. And we need to add the request mapping. And now for this variable to read itself from the URL, we need to say that's the path variable. Okay, and if we call it, what we would like to do, we need to filter this list and find the one with the correct ID and return it. So we will use a stream API from Java 8 with filtering. So we check the ID of each podcast. If it equals to the one we provided. If this is the correct one, then we take the first result. Or if we haven't found it, we'll just null. Okay, so that's something we can start already, but one thing I would like to add before is the server port, because we will have two separate services and they will have the port conflict if they both use the default one. This one will be in 8081 and the second will be 8082. And I will add the application name, not necessary at this point, but later it will help us. Okay, let's run. While it's starting, was it clear enough? Anything you didn't know about or you don't know you would like to understand better? Please ask your questions. Okay, typo podcast service application, correct. But that's because we've called when I generated the code, I said its name is podcast without the camel case, that's why. Start .spring.io, yeah, that's, I like to do it from browser. Okay, we have some errors now, but that's not something critical for us. Why it's happening? Because I've added Eureka dependency when I generated my code, and now the service tries to register itself in Eureka. I will explain it later what it is, but for now it just cannot find the service. That's why it complains. But it doesn't prevent us to do our service calls. So we said it called podcasts, and we take it by ID, and we have the result. So the first is for TV Toronto, and the second will be for Geek Journal. And we have the entire object. The first microservice is created. Great. Now let's go to user service. So user service will consume the podcast service. At the beginning, I will do the same for here, not to forget it. So I provide the port and name. We have the same packages inside here. So first of all, we need to create a model for user, since this is user service. So our user will have ID, name, of course, some information about himself, and we'll have the list of podcasts it's subscribed to. Okay, probably I didn't add Lombok dependency here. I will copy it from podcast service. Oh, it's here. Okay, that's strange. Let's see what's wrong with it. Right. So the service I've just, the zip archive I downloaded, I'll replace all files with the fresh ones. Yeah, this is correct. Now, for some reason, I don't know why it doesn't see Lombok, since I've added this as a dependency. Okay, let's do this. I'll generate one more. And that's what live coding is, guys. Never do this, never ever. Don't repeat at home.
Guys are suggesting to do pre-import for Gradle dependencies.
Okay. To open it from scratch, anyway. We Maven, no, not Gradle. Okay. But now it will take some time to resolve our dependencies, but that should help. Okay, let's do our stuff again. Now we're good. Okay, and what else I will need to do with models? I will copy episode and podcast here. I know in general, we think it's bad practice to copy paste something and to double code, but since we want our microservice to be independent, that's important to do. Otherwise, we can create the library with all our models, but there are a lot of pros and cons in it. But for this project, I'll just create copies. Okay, and now we can create our controller. So again, we'll let Spring know this is REST controller. And so what we need to create here, again, we need to have some data hard-coded since we don't have the database. So I'll hard-code some users. So I have myself here. I'm not actually hosting, but let's say speaking. And I don't know if somebody from Nordic countries joined the webinar, but I decided to have some Nordic guy, Olaf, with me in this system. So we are all both users, but he's not subscribed to anything. I subscribe to both TV Toronto and Geek Journal. And the very basic example what we can do in this controller, just to have the list of users. And next thing I would like to do is to create a method that will get the list, the user schedule, give the user ID to this API, and it will return me the list of my episodes I can watch, sorted by the time they start. So to do this, so here in our small database, we just have everything separate. So I have only users and some podcast IDs, but don't have the actual podcast because it's a separate database. So what I will need to do is to call the podcast service. To do that, we already have the REST client. So probably all of you or most of you already did some calls like this. So the common approach is to use the REST template, but it's already deprecated in the system because it's blocking and synchronous. Instead of that, we will use web client. So what I need to do, I'll create new bin for the web client because we'll reuse it in different places. So we need to create new bin. It looks like this. So we just create new instance of web client builder. With web client builder, yeah, by the way, in the chat, please plus who already used web client and minus who just used REST template. And if you haven't used anything, just keep silent. Okay, good. So somebody of you already used web client. So it's very similar, but as I said, it's a non-blocking version of the same stuff. So we have our bin created. So now we're ready to go and call another service. So here I will do live coding again, just to understand what we do. So first we need to take the list of podcasts I'm subscribed to. Not I, but the user we are calling. So we provide the user ID. And first we go to the stream of users. And as in the previous example in podcast controller, we do filtering. We're interested in the user that has a particular ID. So we have the user. No, we don't have. We just filter and we have the list of users. So we take the first result or null. And then we get subscribed podcasts. That will gives us a list of IDs, not the actual podcast IDs. We can do the call to the podcast service. So again, I'll create a stream based on this collection. And for each podcast ID, I will do the call. So yeah, now we need to call web client. We already created a bin in our Spring application, so we can do auto wiring to just take it from the context. And let's give a name. So here, if we have the ID, we need to do the REST call. To do that, we call the web client and give the base URL to it. In our case, we know that the port for the first service is 8081. So we go to HTTP. That's our base URL. I can build. Sorry, that should be base URL. And then we build. So that's just some preparation. Then we need to let the builder know if it's get, post, or put, or what method we use. And then the actual URI address. In our case, we have the list of podcasts, as you remember. And the list of podcasts, and we give the ID, like which particular podcasts we want to have. In here, we add our podcast ID. Once we have it, we retrieve the result. That will be JSON. And now we do something called body to flux that will transform JSON to the class we want. And that's our podcast class. And now, so the response of all of this I've already written, as you can see, is Flux object. Flux is non-blocking version of response. It means that we don't have the actual response, but we have the promise that it will be returned. So we can compose them and do interesting stuff, but for now I'll just do the blocking right here. So it will, our code will wait for the response. Once it's returned, we have the object we want. But if I have enough time, I will talk about non-blocking approach as well. Okay, here we have the list of podcasts, and now I just need to have the list of episodes, and I need to have them sorted because that's my schedule. So for here, what I need to do, for each podcast, I will get the list of episodes, but since it will return the list of lists, if I do just mapping, I will do the flat map. So the list of lists will be transformed just to flat list. If you don't know what flat map is, just in case. I'll get the episodes and stream. And then we need to sort the result. And to sort, but we need to sort by the date, not any other field. So we'll have comparing episodes get start time. And then just collect the result. And we're ready to return our episodes. Okay, we're good. Let's start and see. So all we did before is not really the microservice stuff. It just created two applications, but after that, we'll transform them to microservices. First, just a simple test. So as you can see, this service complains about Eureka as well, because we added that dependency. But very soon we'll fix this. For now, we just should be able to get the schedule. Did I provide a port? No, I didn't provide for this one. So it's 8080 for now. So let's see what's wrong here. Right, I didn't say what's my request mapping for this one. But I think it should work without users. Yeah, so I wanted to have the schedule for user number 1, and I subscribe to both podcasts, so I should see all episodes, but they are sorted in from the earliest to the latest one. So that is correct. So what we have is just two separate applications, one interacting with another. But what if we want to transform it to microservice, meaning that we should be able to scale? What the problem right now is that we are calling the particular URL, which is localhost and port, meaning that if we scale and we, for example, create another instance, it will be in the different place. So it will be still the same network, but at least another another port. So what helps us here is Eureka. Eureka is the product of Netflix, as I said before, and that's a framework that uses a pattern called service discovery. What is service discovery? So if we have one service but many instances, we just say what service we want to call, not a particular instance. How to achieve that? Let's first the stuff I forgot about. provide a name here. So to achieve that, it's very simple with Spring because Eureka is integrated Spring ecosystem. So we have our bin here. All we need to do just to say that this web client is load balanced. And then when we call the service, we don't say the actual URL of it, but we just say which service we want to call. So I'll say podcast service. That's not really URL, but since we've already told web client that it should be load balanced, it will dynamically transform this URL to the correct one. So it will look for this service called podcast service, and we'll find the instance that is available, and we'll call it for us. Let's do the test. It will fail right now. At least it should, because I don't have Eureka started. But after it fails, we will start Eureka and see what happens. So we started a bit later, so I guess we are still on time, even though it's 7:05. Are we good?
Yes. But
Okay.
even though if somebody needs to run, we will have the recording of the webinar, and you are kindly asked to fill in the Google form to receive the link to the recording after all.
Okay, so we call the correct port now. So now I want to get my schedule, but we have the internal server error, which is correct because there is no podcast service we would like to call. So to fix this, I need to start the Eureka server. What is Eureka server? It's another Spring Boot application, as usual. To create a Eureka server, we just need to add one dependency called, so previously we added this Eureka Discovery client, and now we add the server. And we give the name. And generate. Again, I have something already prepared because that's very simple application. I won't even import it. So I'll open recent. I have Eureka Balancer. So after we've imported our project, the only one string of code we need to add is the annotation enable Eureka server for our main class. And that's it. There's nothing else I've added. But just the server port, why I need to do this. As you remember, we have some errors in the previous services. So they are trying to find the Eureka server, and by default, they're looking for localhost 8761. So I just use the default port to make everything work together. And those two properties is just to disable this application as Eureka client as previous ones, because each server is by default client as well. But since it's not the client, it is not going to looking for other balancers, then we just say it's false. And now we start this one. Then the magic should happen. Okay, so you see something in the log, something like registered instance of podcast service and user service. How it happened, as I said, those applications are pinging localhost 8761, and since the Eureka server is up and running, they registered themselves. And we can check that by calling Eureka. It opens an application with some UI, and we already see what instances of we have. So we have 2 services with 1 instance for each one. So as we started before, so just 1 instance. And now the call that failed should work. At least I hope so. Yeah, so the magic happened. As I said, I just say, give me podcast service and call this URL for it. Now our controller called Eureka and asked, give me the address for the particular instance of the application. And that happened. So what benefit it gives to us? We can now scale the podcast service. Let's imagine it has very high load and we don't have enough memory for it. So we just start 1 more instance. So we cannot do that from IntelliJ. At least I don't know how to. So I'll create a jar and start it as a jar file. Okay. And now, so what we need to do, there seems to be the correct service. Didn't see my jar built. Yeah, here it is. So since that's the standalone application, it will start the Tomcat inside itself. So I just need to say, need to run the jar file, and we need to give another port to the application. It will replace the default I've added to Spring config, because otherwise another port conflict will appear. And the name, here we are. Start a Spring Boot application. And as soon as it starts, it will try, as previous services, to register itself in Eureka. Once that happens, we can refresh Eureka. And now we see that for podcast service, we have 2 instances. So what happens for the user service here, if I say, give me podcast service, and I run some URL for it, I never know which instance I'm calling, because it's all up to Eureka which one we should call, because that's load balancing. If the first instance is high loaded, then it will call the second one. Otherwise, vice versa. Also, we can scale it up to 100 services, as many as we need. And why I mentioned that blocking is the problem if we use the old blocking approach here. So we do the block first. it will still work. It's all fine with this, but our performance will be a little slower with blocking approach. Why? Because since we have the stream, and when we do the map method and we provide the function for it, our lambda function. So it will call the first one. Then it will take the flux immediately. But since we're do block first, it will wait until we have the result for the first call, for the first podcast. Then it will call the instance of podcast service again. It can be different one, but again, we'll wait for the response. If we do non-blocking approach, it will return the flags immediately, and it can point to different instances in the same time, and then we can decrease the time for having the result depending on how many instances we have. So we use all advantages of microservice approach. But since we don't really have time to write this code, because doing like composing features and promises, reactive programming is a little bit more complicated, so probably we'll do that next time. But now we have the fully functioning microservice application with just 2 services, but I think that's great for just 1 hour, and that's how Spring Boot really helped us.
Thank you, Viktor, for this magic, as you say. Thank you, dear guests, for attending this webinar. Please don't forget to leave your feedback, and we'll send you the recording in return. I just copy-paste the link to the Google Forms. Also follow our social media to get new announcements of our upcoming webinars. Thank you again, Viktor. Thank you again, dear audience. Bye-bye.
Any questions, by the way? Okay, let's go one by one. If we have a monolith application now, how would you recommend to approach splitting into microservices? Where to start? Yeah, that's a good question. So it's all about the common sense, first of all. As I said, there are main principles, like keep them small and independent. So first thing, you need to understand where is the independency of your services. What can you split, not to touch anything else? So for example, like users or some other entities, if they can be independent, then that can be the first microservice. If there is some dependency, then this should be refactored, because you will have to create separate databases and separate code bases. But first start from the independent things. At the beginning, you can have not microservices, but macroservices, meaning big services. But you can still do the same approach and scale them. At least you will have advantages at the beginning, because it will be lower cost for servers or cloud. And you can do scaling, you can use all Netflix libraries to interact between services, etc. And then it's all about common sense and like your needs. The second one, how to approach integration testing in microservices architecture, some quick tips where to look. So look at other Netflix products like Ribbon. So they have the framework itself has different libraries for testing in particular. Just 2 questions. Another one. In the real world, the data which is needed for microservices is not fully isolated. Some data has to be shared. Users, do we have to copy the data into 200-300 databases? How to deal with synchronization, sending on opposite. Okay. So we don't need to copy the data into the database unless there's a big performance need. I mean, ideally, for example, if you don't have the data you need, but you can just have IDs, and the example we had, you call another microservice from your first service, and it will provide data for you. So yeah, then it doesn't have to be copied. But if you really need that for the performance, because the calling in separate service is time consuming, then you need to find the proper place where to do that. And for synchronization, for example, if you have different databases and they really need to be synchronized, so there is no way to get rid of it, then you can, for example, have Amazon AWS Lambda that will synchronize them. And that will be costly, but that will work. Okay, what else? Sending all possible required data within request puts higher pressure. Yeah, that's what I already said. It will be higher pressure, but then you will have the way to scale only the parts you need. And that's the point of whole microservice question. Would you recommend to split database if the application was split already to small modules? What problems can appear in this case? Do you mean that the database is the monolith database, but we have separate modules in the code? Okay, yeah, definitely. Because if your application is already split into different modules, that will really help you to migrate to microservices. Because then you can use like something like Spring Boot, or just create a separate code base for your module and run it in the Docker container. So it doesn't have to be the Spring Boot, or I don't know, you can actually use something else, not even Java, but just knowing about the principles I've already mentioned and run it as a microservice. What's the benefit of what? Of having the separate databases, you mean? Okay, so if you have the separate database, so what is the whole question of scaling? We need to scale something if we have the high pressure or the high load. If the problem is in memory, then we scale the service itself. But if the problem is in the database, so the number of transactions is too high and the database becomes slow, meaning if we call one table that affect all other tables. If we split it, then we can copy, like do many more instances of the same separate small database. Why do we need integration testing? Why when we have fully unit tested microservices? Yes, we do. Just to see if we change the API for the one service, that shouldn't be done, because we always need to think about backward compatibility. But if that requirement is not met by, let's say, other team that works in the other microservice, that's why we need integration test to see that everything runs together. Security in microservice environment. Yeah, that's a common question. So for security, you need to have just one authorization service. It's microservice as well, but if we, for example, scale authorization service, it will have something called sticky sessions, meaning that session will be shared between different instances of the same service, and that will be our start point. So if we do the secure calls from our UI that will go to authorization service first. It will check if the user is logged in, and then it will resend the call to the actual microservice within the local network, meaning that all our services are in the same local network, so we don't need to check authorization data for each call, because we trust the service that is in the same network. But if we do the secure call, the first endpoint is a secure microservice. How to manage number of instances. So Eureka is just the service discovery. So if you start new instance yourself, like in the local environment for testing, is just creating new instance, calling your jar file. But in production environment, there are several approaches. For example, Kubernetes that can help you. So that's another topic. Probably that will be the second topic of our webinars about microservices. So Kubernetes is the framework that helps you to manage this chaos of hundreds of instances and so many microservices. Is there an approach without Kubernetes, without Docker? Yeah, the AWS itself has a lot of different stuff. I'm not an expert I know it works, but I cannot give you the particular example of AWS instruments without Kubernetes. If that's really the startup, I would just recommend you to do that manually. So I'm literally starting new instance. And if you have Eureka in your ecosystem, it will just discover the new service and will add it to the list. Yeah, I don't like Kubernetes either. So I'll dig more into the same topic. Okay, anything else, guys? Thank you guys for your questions, and thank you for your passion. Thank you to be patient and to listen to the end of this speech. And let's do the microservice shit now. If you have the monolith, you can start right away.
Yeah.
Now it's time. Thanks again.
Thank you, Viktor.